So given an array of integers, nums, and an integer target, return indices of the two numbers such that they add up to target. Okay, so we've got an example array here. And I'll move a copy of that down here. We've got our example array, 4, 5, 8, 9, 2, and we've got our target, which equals 11. And by looking at it relatively quickly, we can find that 9 plus 2, when added together, equals 11. And those are the only two numbers that add up to our target. So let's continue reading on in the instructions here. So you may assume that each input would have exactly one solution. Okay, great. So in our example, there's only one solution, 9 and 2. And you may not use the same element twice. So if there, let's say that the target was equal to 10, and in that case, we would not be able to return 1 and 1, because that would be the indice that has the element 5. And 5 plus 5 equals 10. So we couldn't do that. It has to be two separate numbers. And we can return those numbers in any order. So in our case, the answer is 3 and 4, as those are the indices of the elements that add up to the target. And we can return them like this, or we can return them like this. Either is totally fine. So the easiest and most straightforward approach would be the brute force approach to this problem. And the way you would do that, the way we would do that is we'd have an eye on the first element in the array, and then we'd go through the rest of the elements in the array and check to see if they add up to the target. So 4 plus 5 is 9, doesn't add up. So we move over to 8, we check 8. 4 plus 8 is 12, it doesn't equal 11, so we move on to 9. We do the same thing there. 4 plus 9 is equal to 13, and then 4 plus 2 is equal to 6. So since none of those numbers added up to 11, we can actually go ahead and remove 4. We can just completely forget about it, since we added every other number to 4, so we wouldn't have to go ahead and re-add any number with 4 to see if it equals 11. We already know that none of them do. So now we're on 5, and we do the same thing we did with 4. We check every combination with the other elements in the array to see if they equal 11, and they do not. So we've got 5 plus 8, 13, 5 plus 9, that's 14, 5 plus 2, 7. So we can get rid and totally forget about 5. And then we've got 8. So we'll do the same thing again with 8. We have one eye on 8, and then we check to see if 8 plus 9 is equal to 17. To 11. Nope, it's equal to 17. And then 8 plus 2 is equal to 10. So we can get rid of 8 as well. And then finally, we're at 9. And we check 9 plus 2, 2 being the only element left in the array, is equal to 11. So there it is. 9 plus 2 is equal to 11. And we would return the indices of those elements, which is 3 and 4. And the time complexity of doing it this way is O of n squared. And now the reason why it's O of n squared is because if we look at the equation here, you might actually wonder, what is O of n and big O notation? And those time complexity things can be rather confusing, and sometimes we just memorize them so that if asked, which does happen, you can give the right answer. But oftentimes the interviewer doesn't even really know or fully understand big O notation. And so it's kind of like in my opinion, a little bit of a broken thing in interviews, but it is still something that's important. And so here's a brief description of big O notation. So big O notation, which is this symbol here, O of n squared or O of whatever, this big O notation describes the upper bound of the time complexity in the worst case scenario. But if we look at the actual problem here, in this particular problem, this problem has an equation, or this algorithm has an equation of 1/2 times n squared plus n divided by 2, and then all of that is subtracted by 1. Now, don't worry if you don't know how I came to this. It's not important here, but this is the actual amount of time it would take as n grows. This is the total amount of iterations that the algorithm goes through to find the problem in the worst case scenario. So this is actually the worst case scenario of the algorithm, the brute force solution we have created for this particular two-sum problem. However, we're all the way up here saying, we're saying, oh yeah, the time complexity is O of n squared. Well, it's not O of n squared. Actually, in the case where n is equal to 5, this equation comes out to equal 14. So it seems a little bit misleading. Why are we saying that it has a time complexity of n squared? Well, what O of n, what big O notation really is about is it's about highlighting the relationship between the amount of time an algorithm will take as n grows in size. So if we look at this equation here, big O notation ignores constants and it ignores lesser terms. So we've got 1/2, which is a constant, so we can remove that. And we've got -1, it's a constant. And then we have a lesser term, n divided by 2. So for example, if n is equal to 10, n squared is going to be 100, while n divided by 2 is equal to 5. So n squared grows faster, and therefore we get rid of this lesser term here. And so therefore we are left with n squared, which is what we end up saying our time complexity is. But really it is, if we look at a graph here, and look at a graph here, this could be, n squared, but our actual solution could be this here. So it's not necessarily going up as fast, but we have an idea that it's at least some roughly close to n squared. And that's why we use big O notation. That's all that really is. So anyway, let's move on to a more time efficient solution here. And the more time efficient solution has a time complexity of O of n. So what is this algorithm that has a time complexity of O of n to solve this problem? Well, we're going to pass through the array one time and not more than one time like we did when we were solving it using brute force. And as we go through, we are going to store data inside of some sort of data structure, some sort of data store. And we'll call this data store Hank. And Hank will just be a nice entity that lets us put numbers in him in a way that's not weird. And so basically, what are we doing here? We're looking at our target and we're saying, okay, it's 11. And we're going to subtract numbers from that target. So we'll say 11 minus 4, which is the first element in our array, equals 7. And we're going to check to see, hey, is 7 inside of Hank? And 7 is not inside of Hank. But why are we checking this? Why are we doing this? Well, just like we can add two numbers together to get the target, so 9 plus 2 equals 11, we can also subtract from 11 9 to get 2, or we can subtract 2 to get 9. So as we go through and loop through our array, we can, after every single element, we can add that element to our data store. We can add it to Hank. And at some point, we'll get to a point where we subtract a number from our target, and that number exists inside Hank. And that, in our specific case of this array, it will be 11 minus 2. And 11 minus 2 will equal 9. And we will have put 9 in our data store by that point. So let's go through, and it'll make more sense as we go. So 11 minus 4, 11 over here minus 4 over here is equal to 7. Since 7 is not in our data store, we will add 4 to our data store. Then we will check the next element in our array. So 11 minus 5. 11 minus 5 is equal to 6. 6 is not in our data store, so we will add 5. And we'll continue doing this with each element in our array until we find a value that is in our data store. So since 3 is not in our data store, we will add 8. And we will go through again. 2 is unfortunately not in our data store, so we'll add 9, which is the element in the element that we are subtracting from the target. And now finally, we will subtract from the target 2. It's the last position in our array, and that equals 9. And we check, hey, is 9 in Hank? And it is. It's right here. So we know that we should be returning from the function, or from this algorithm, we want to return the indices of the elements that add up to target in our initial array. And so we know we're looking at 2. We have an eye on 2 over here. We're like, okay, so we know that index of 2 is 4, but we're pulling the value of 9 from Hank, right? And at the moment, Hank, it's only 9. Like, we don't have the indice or the index of 9 tied to it anywhere or associated with it anywhere in Hank. So what we need to do is we need to structure Hank as to where he can take 2 values per entry. He can take the actual number 9 and then also take the index of 9, in which case is over here, top left, 3. So initially we were not adding that into this blob sort of looking data structure, but we will be adding it as we go through now. So now we have discovered that we want to add both the value of each element in the array, as well as the index of that element. So let's go ahead and do that. All right. So we'll still call him Hank. We'll have Hank over here. And Hank, well, beautifully shaped Hank. We've got a key and we've got a value. Okay. So let's go back through our array and do the same thing, but this time we're going to store both the value of that particular element in the array as well as its index. So 11 minus 4 is 7. 7 is not in the key of our array, and so we will add 4 along with its corresponding index, which is 0. Now I want to mention early on that this is known as a hash map. Hank is a hash map. And that can seem very confusing at first, a hash map. It sounds like kind of a daunting data structure. But all it really is in the implementation of JavaScript, a hash map is just an object. And in Python, it's a dictionary. All it really is a key value data structure where the keys are unique. And that's what makes the time complexity easier to, that's what makes the time complexity O of n is actually this hash map. That's the big key. No pun intended. So more on that in a little bit. Let's continue going through. So 11 minus 5 is 6. 6 is not in any of the keys. 6 is not a key in our hash map. So we will add 5 along with its index, which is 1. We will check 11 minus 8 is 3. 3 is not a key in our hash map, so we will add 8 and 2. Then we will check 9. 11 minus 9 is 2. 2 is not in our hash map, so we'll add 9. 9 and 3. And then lastly, we'll check 11 minus 2, which equals 9. Is 9 a key in our hash map? And it is. It's right here. So now when we return from this array, when we return from this algorithm, this solution, we want to return the index of 2, which is 4, as well as the value, the index of 9. So we get the value, we get the index of 2 from the actual array, and we get the index of 9 from the hash map. There we go. So there's our solution. And now why is this O of n? Why wouldn't this be O of n squared? And the reason that this is O of n is because since the keys in this hash map are unique, Hank knows when we say, hey, we're looking for, we said 11 minus 2 when we were checking here. 11 minus 2 is 9. And we're like, hey, Hank, do you know if you have 9 in your keys? And because the keys are unique, he doesn't have to iterate through, oh, let me check 4, 5, 8, 9. No, he knows exactly. He knows immediately exactly where 9 is. So he's like, yep, we're right over here. And that takes O of 1 times, meaning the time complexity of looking up where 9 was for Hank only it takes a constant time. It takes a constant time, meaning if n, meaning our array, if n was equal to 500, so if Hank had, hundreds of different keys to search through, it's okay because he will find a key in the same amount of time, no matter the size of n. And it's the same with adding. He's able to add a key value pair, a key value entry into himself in constant time, okay? It doesn't matter how big n is, it'll take the same amount of time to add and to find a value in himself, inside the hash map. So because O of n is greater, it's a greater term, n is a greater term than a constant, we ignore the constant and we stick with O of n being the time complexity for the solution. All right, so now let's go through the two solutions we saw in both JavaScript and Python. All right, so let's start with the brute force approach in JavaScript. So we're going to start off with a for loop where we let I equal 0 while I is less than the length of nums, so nums.length minus 1. And the reason we have a minus 1 here is because We never want that outer for loop to reach the very end, since there's two elements that need to be added to each other in the array. We never want that outer for loop to ever reach the very end. We want to just hit the second to last spot inside of our array. So then we will increment I plus 1 at the end of each for loop. And the only thing inside that outer for loop will be an inner for loop. And we'll declare a new variable called j, and we'll set it equal to I plus 1. So at the beginning of iterating through, for each new iteration of the outer for loop, we will set j equal to I plus 1. And this for loop should execute the code inside of it while nums.length, while j is less than nums.length. So that will go to the very end, the last element in the array, and run on that. And lastly, we will increment j plus 1 as well. So j plus plus is the same way of saying j plus 1. And now, what do we want to do? Well, we want to check something, right? So we'll say if, and we'll see, does nums at I plus nums at j, does that equal to target? And if it does, we return, what do we return? We return the index, the indices of I and j. Well, we return the indices of the elements, and those indices are I and j. So let's go ahead and return this and just make sure it works. All right, great. Now we will check the one pass hash solution, we can call it. We can call it the hash table solution, and this will be the more time efficient solution. So let's go ahead and do it. We'll start off by creating an empty hash table, which is just going to be an object. So we'll call it, how about we call it Hank, for all time's sake, for our buddy Hank. Let Hank equal an empty object, and this is going to serve as our hash map. Remember, the implementation of a hash map in JavaScript is an object, so that's why we've declared Hank and set him to an empty object. So now let's go through this array one time. We won't have a nested for loop like the last time. We'll set I equal to 0, and while I is less than nums.length, so basically this for loop will run for every element in the array. We'll do I plus plus at the end to increment by 1, so we go through each element. And what are we going to do? Well, we're going to check something, right? We're going to check if target minus target minus nums of I is in Hank. So remember when we were checking to see if these numbers were in Hank? That's how you do this here. And in JavaScript, you can use the in keyword to check keys or to check property names of an object, if property names exist in an object. So in this object, we're checking to see, hey, does target minus nums of I, meaning nums at the first position of the array, is that a property name or a key name in Hank? And if it is, we will return what? What do we want to return? Well, we want to return the indices of the array that add up to target, right? So we will return Hank at target minus nums of I. And the reason for that is because Hank at target minus nums of I is going to give us the value. So we're passing in the key to Hank. We're saying, hey, what is the value here? And that's what it's returning. And remember, the value in Hank is going to be the index of the array at the particular position we are looking at or looking for. So that's one indice. That's one index. The other index is going to be I. And that's it. So the only other thing we have to do is, if this isn't true, which in pretty much in every single case except one, this won't be true. So what do we want to do? We want to set Hank. We want to add a key value pair into Hank. Okay? And how do we do that? Well, Hank takes a key value pair like this. So we want to set nums of I, right? We want to set nums of I, and we want to set the value to be I. So we want the key to be the element in the array, and we want the value to be the index of that element in the array. And there we go. That should be good to go, and so we'll run it to make sure. And boom, there it is. And we shaved off 3 milliseconds. So look at us go. I'm proud. All right, so let's go ahead and solve this in Python. And the first thing we'll do is the brute force nested for loop approach. So we'll have for I in range of length nums minus 1. And what's going on here is we're looking at nums, the length of nums, which let's say that it's 5. That would give us 5. So it would find the length of whatever the array or whatever the list is, and then we are subtracting 1 from it. So if nums was a length of 5, then this number would be 4. And what range is doing is it's looking at the value inside of it, and if we only supply one value, it'll serve as the stop value for the range. And basically the stop value, if the stop value is 4, it will give us a sequence of numbers up until 4, starting from a base of 0. So it'll give us 0, 1, 2, 3. So this is a length of 4, as we can see, but it has a base index of 0. So we exclude 4, we just go up to 3. And so basically what this is saying is that we're going to iterate through 4 times, while I is 0, while I is 1, while I is 2, while I is 3. So in our inner for loop, we'll have for j in range, and we'll start, remember we want to start at the position of I plus 1. So range has 3 values that it takes: a start number, a stop number, and a step number. When you add just one value like we do here, it will be the stop number. When we add 2 values, it'll be the start and stop numbers. So I plus 1 is where we want to start that inner for loop on each new iteration of the outer for loop. And then we want to stop at length of nums. And there we go. So now inside this inner for loop, we're checking something, right? So we're checking if nums of I plus nums of j is equal to target, right? And if it is, then we will return the indices of I and j. Let's go ahead and run that and make sure it works. Okay, great. So it does. Now let's do the one pass hash map approach. So we will do, and I'm saying one pass because we're only going through the length of n one time. Like we're passing through the array one time only. So we'll start off with a for loop for I in range, for I in range of nums, length of nums, and we want to declare our hash map. So we'll say hash, we'll call it Hank again. Hank equals an empty dictionary. And so for our for loop, we're going to check something. We're going to say if target minus nums at I is inside of our hash map Hank. So this in keyword also allows us, while it allows us to loop through a list, it also allows us to check to see if keys are present inside of a dictionary. And so if this is true, target minus nums of I is in Hank, then what we will do is we will return the indices, right? So how are we going to get the indice of the key? How are we going to get the value, aka the indice of the array of that particular number in Hank? So the way we'll do it is we will call Hank. We'll say, hey, we want you to return the value of this key. So we pass in the key to Hank, and this right here, Hank will return the value, which is going to be the indice of this element in the array. And then the second index is I. And so that is pretty much all we need to do there in an if statement. And outside of the if statement, remember, this will only be true one time. And so for every time it isn't true, we want to add a key value pair to Hank. So all we have to do for that is say call Hank and pass in the key. So the key is going to be it's just going to be nums of I, and then the value is just I. And so that should do it for the second solution. Let's run it and make sure that it works. Uh-oh. Unindent does not match outer indentation level. Oh, okay, that should work now. Interesting. Okay, there we go. So it was just an indentation error, as Python is sensitive to indentations. So that's it.